Hello guys and girls, today I have a small announcement to make. After procrastinating for years, I finally managed to Tasmotize a cheap energy smart meter which is based on the BL6523GX chipset. So there are many variations of this smart meter. I think at least 3 different chipset based smart meter products exist, and this is one with the BL6523 Belling chipset, which is a very accurate power monitoring chipset with a lot of features. So let's see a small demo. So here I have connected the smart meter to the power, and I have wired an ESP8266 which I will explain how to in a moment, and I have connected a Tasmotized electric bulb to it, and let's move to a tablet here where I can demo. So as you can see, so as of now I have coded to report these parameters: amperes, voltage, frequency, watts, power factor, and whatever. So so I have a template which I'll share pretty soon. So you need 3 wires to be connected from the main board of the smart meter. It's just RX, TX and ground, and then power the ESP module. So there are different ways you can do it, which I will explain in a minute. So here is the Tasmota UI for the bulb that I have connected. So if I do the brightness full, it's already letting it in my face. You can see it's consuming almost 12 watts. Power factor is 0.53. It's typical of this. I think it's switched non-isolated power supply. So, and then whatever, 244 volts, frequency 50.01. I don't think I need to be this accurate on the frequency. I can, that's fine. And the ampere. So while developing this one, I also found that the actual display in the meter, the actual code that is driving this display has got a bug only in the power factor thing. So the power factor won't report accurately if the power factor is below certain limit. So right now it's saying 0.00. So if it is way below 0.5 power factor, the power factor is always it's either very low or it's even displaying as 0, and it's only 2 digit. So what I found out is that it's not processing all the bits that's available. It's around 23 bits of value that you can process to get a very accurate power factor from this chipset, which the code in the microcontroller, which is responsible for getting the data and displaying on the LCD screen, is not processing correctly. But with this after Tasmotification, as per this firmware is using all the bits, so you can get very accurate value for all this. So that's it from that's how the current state of the code is. Now let's see what you need to Tasmotize one. If you have a BL6523 based smart meter, let's say what you need to Tasmotize this and get very good power reporting to wherever you want it to be channeled. So let me, if you see, so I think if you look at the console, it's reporting, yeah, all the things that you see in the console is reported. So I just coded it as a sensor because I don't see, I didn't really understand the key difference between an enrgy peripheral in Tasmota and SNS peripheral. For me, the sensor seems to be more than enough for Tasmotizing this, but maybe I am not well educated. Maybe it's because I didn't see the actual benefit of or the actual differentiation between enrgy and sense. If someone can explain me, much appreciated. So let's go to the connections. So this is how the energy meter looks like if you have a BL6523 base smart meter. So this is it is if you just remove the 3 screws and open it up, it is 2 different subunit, right? The front part where the display is, it has got a CPU and an LCD. The CPU's job is to initiate the second part and keep reading the values, the power values, and display it. There is it also has the value. It also it also saves some parameters in an EEPROM here, which is a totally independent unit, which we don't need to consider for our Tasmotification or IoTification, if we choose to say that. So that there is an I2C bus SDA SCL that is totally independent of any other communication. Then there is the RxTX, which is for our main chip communication. That's where all the data gets accumulated and sent over to this LCD. That's what we are going to tap. So we are only going to tap 3 wires, RX, TX and ground. Then because I found out, I will tell you what the others are. There is also a line called DN, so display enable, and there is also another line called 3.6 volt. So what these are, there is a nickel metal hydride or nickel cadmium 1.2 into 3, that is a 3 cell battery pack in the main board. So what it is used for is, even if you are not connected, even if you haven't plugged in this smart meter, you can check how much units you have consumed. If you press the button in front of it, it will show. As long as this battery has some power, it will show, and it will automatically turn off after 5 seconds or whatever, some time out. So for that, there is this power is connected to the 3.6 volt, right? So this 3.6 volt is only when you press a button while it is not powered on. It will wake up the CPU. It will show the values. Those values are coming from, I think, from this EEPROM, right? So those are that is the part which is totally independent of the actual sensing of the parameter. So we can isolate and leave that, and then there is a pin called DN, right? So when you plug in this device, it will have a high on the DN. If you enable a high, anything between 3 volt and 5 volt, a high signal, a TTL high signal, if you make this line high, what the CPU will do is CPU will wake up, it will send the initiating command or mode setting command to the BL6523, and then every second it will keep on reading the BL6523 for the parameters that I showed you. So what will happen is, as soon as you powered in, DN get enabled, CPU wakes up, CPU sets some modes and calibration to 6523, and then each second it will send a command through TX, which will come to RX in the BL6523, and the BL6523 send the response. So this will keep on happening every second for each one, for any of the parameter, right? The parameter can be what is that? So any of this, amps, voltage, what is the voltage, what is the frequency, what is the watt, what is the power factor now, what is how much watt hour. So these keep on happening. So that's what we are going to sense, what command, what value, and then send it all together, right? So that's what's happening in my Tasmota code. So let's go back. So now what you need to Tasmotize this, right? So you need either an ESP8266 or ESP32, ESP32S3, ESP32C3, anything that the current Tasmotizer code base supports. It supports a lot, so you can use any of those. So I would suggest getting an ESP2 approximately to $1.5 ESP2. So you need something which has got GPIO4 and GPIO5 exposed. So initially my plan was to use ESP01 so that the overall cost can be $1 or for the module $1. But the problem is, right, so ESP the GPIOs that are available in ESP02 is not really suitable for this. It should be input capable, and it should not tamper the actual boot process. So 4.5 is the most safe to use for input in ESP8266. So I would suggest something like ESP12, 12E, 12F, 12S, doesn't matter, any of the 12, or even better, get a VMOS D1 mini, which can be a pretty nice size, and it already has got this GPIOs wired out, and it also got a CH340 based UART or a USB UART, so you can easily program. So it's up to you. So if you can directly solder wires to ESP12 module, better. If you don't want to do it, get a VMOS D1 mini, just $1, maximum $1 difference. That is the best. Or if you want to go a little bit higher, you can go for ESP32 or even ESP32C3 if you want to experiment more, right? So you can do that. I don't have any thing. My code should work anywhere. If it is, I have tested using ESP8266, but I can support to make it work. I think it already works on any of these, but if someone I can test myself, and if somebody wants to test before I can, most welcome. I can build it for you if you want to test it before I raise the PR and get it merged. But yeah, that's all. So you need a ESP. Second thing, you need to 1k ohm resistor. This is to make sure that the 5 volt or even the 5 volt logic level of BL6523 won't really, even though the ESP says that it is 5 volt compliant, I don't know, because it's totally non-isolated AC, right? So it's better to use 1 kilo ohm resistor while connecting. Okay, I forgot to mention that. Let's do this. So you need one K. So you need 1K resistor to connect your TX and RX to GPIO 4 and 5 respectively. And then you need a power supply, right? So if you are using bare module, you need to provide it with 3.3 volt. In that case, you can get a 3.3 volt SMS for $1, $1.5. Isolated power supply SMS bare module, or you can even get a sealed black power supply, 3.3 volt, 220 or 90 to 220 wide voltage range to 3.3 volt power supply, which you can connect between the ground and the 3.3 volt of the ESP, and then connect the line and neutral to the line and neutral in the main board, or directly to the plug of line and neutral, so that the power factor of this mode. So you shouldn't connect this to line out, because in that no, you should connect this to, you shouldn't connect this to line out, otherwise the consumption of this module and the power factor of this module will interfere with whatever the actual load that you want to measure. So always please connect directly to the line in, not to the out. Neutral anyway doesn't matter, because it's just same for both line in and line out. No, so both in and out, but line in and line out is different, because line in is where the bottom part and line out goes to the top part. So you should connect it to line in. There is also another way to avoid this $1.5 part. There is a capacitor dropper for powering all the BL6523 in the board. So how that works is, so first the capacitor dropper will drop to 12 volt, which is available in the same strip where this ribbon cable connects to here, but it's not connected. So you can easily get that 12 volt, get a AM117 3.3 volt LDO regulator, and then try to connect. I haven't tried it. You need to have a big capacitor at the 3.3 volt side, because the ESP can spike whenever it transmits. So that will will save you at least $1.5, right? So you need only a AMS 117 3.3 volt LDO. So if you connect this 12 volt, this is on the main board, there is a 12 volt and ground. I don't know if all the board variants are, in my power module it has it, right? But the safe way is to get a 3.3 volt SMPS if you are using module. If you are using VMOS D1 mini, right, so then you use a 5 volt SMPS, or if you are going through ultra cost saving, you use a 5 volt AMS 117 LDO to connect to. So the VMOS already has a 3.3 volt regulator in the baseboard. So you can, or you can, it doesn't matter, you can directly connect to 3.3 volt in the VMOS also. So it doesn't really matter, but yeah, it's up to you. You know what I mean, right? So the ESP is actually a 3.3 volt, right? So so the module you need anyway 3.3 volt. But if you have other power related stuff, like a relay, 5 volt relay to power, then you can use a 5 volt power, and then you use the regulator to get the 3.3 volt out of 5 volt. In this particular case, I don't have an intention to make this. I thought about it, but I am not sure. Even if you can use 3.3 volt, right? So my intention, what I meant is that even if you want to change it to a smart energy monitor with smart plug, right, where you will add one more relay to switch your line out before it goes to the output port. So you can add, because we have Tasmota, you can do anything. So you can turn on, off, as well as you can keep monitoring the energy. That's also possible, but I don't have any intention. But this one is its primary goal, right? To send the very good power monitoring values that you can get from this very good chipset BL6523, get it logged somewhere like Home Assistant or domotics, or whatever your preferred home automation or energy monitoring software. So that's what you need. So you need one smart energy monitoring plug, which is BL6523 based. So if even if you don't have one, you can get it, because either you will get a BL6523 based, or you get some other chipset based, which is already supported, right? Which is already people have. I am not sure if they added it to Tasmota, but they have already um, IoTified it. So the protocol, everything is decoded. This is the last one which is not done, which I have done. So you can get it right away. Get it, even if you didn't get BL6523, doesn't matter. You can Tasmotify it. So for this particular thing, you need a BL6523 board smart energy plug. And then a ESP8266, either it can be ESP8266 module, or a VMOS D1 mini, or a ESP32 based module, or ESP32 based module. So if it is not thing, if you get a bare module, to program it, it's little bit different the first time when you transmit. After that you can do OTA, no problem, but the first time task notification is trouble. So that's why I suggest you to get a VMOS D1 mini. You also have to consider the size, right? If you get a very big module, there is not enough space to put it inside the cabinet. Then two 1K resistors and a power supply. The power supply either can be this one, or if you want to experiment with ultra low cost, use a AMS 113 LDO and try to get the 12 volt converter to 3.3 volt. Add a at least 470 microfarad capacitor at the output stage, so that the spikes can handle the spike. But I prefer to use a standalone SMPS 3.3 volt 500 milliampere or 300 milliampere enough. Yeah, it's very cheap, right? It's very small and it's very cheap. So I can show you how I have pasted it. So yeah, it looks like this inside the. It's so small. This is the power supply, and I have connected the wire here, and the positive and negative. This is I use the 3.3 volt power supply, isolated power supply, but you can use depending on either 5 volt or 3.3 volt. So that's it. So that's all in this video. And then you need hot glue, wire, soldering and solder flux multimeter if you want to test something. Those are the tools you need to do to perform this mode. Anyway, so you only need the four things, right? You need the energy meter. If you already have energy meter, you need a ESP based module, ESP826, ESP32, any of it. You need two 1K resistor and a power supply. So all together, what, 3 plus $5, all together $5 USD. That's all you need to convert this energy meter to a connected smart energy meter with very good accuracy. So I'll be merging the code and raising pull request soon. But before that, if you want to try, let me know in comments. I can send you the binary. If you, even if you want ESP32 based or ESP32 something else based binary, I can compile and give it to you. Otherwise, you can wait for my code to be merged to mainline Tasmota. So yeah. So that's all from me for this video. Thanks a lot for your time, guys and girls. Happy making, happy hacking. And if you haven't subscribed to my channel, please do it. I will be posting more of similar videos, and I will also be doing a code walkthrough and the protocol analysis um, uh, tutorial for this hack, how I found all this and how I coded the thing, so that others can enhance it, understand it and enhance it and make it better. So thank you for the time. Have a good one. Bye.